Hello everyone, welcome. Today you will be learning about evaluating limits. We will use laws of limits, or we will be aware of the laws of limits while we are trying to solve problems involving limits. Recall earlier on we learned two rules. The first one is a limit as x tends to a of x equals to a. For example, we had a problem like limit as x tends to 3 of x, that will be equal to 3. The second rule says the limit as x tends to a of c, where c is a constant, will be equal to c. For example, if we had a question like the limit as x tends to 3 of a constant, let's say called 5, that will be equal to 5. Now there are some other laws or rules that we need to learn about today. So it says let f of x and g of x be defined for all x is not equal to a over some open interval a. Assume that L and M are real numbers such that limit as x tend to a of f of x is equal to L, and limit as x tends to a of g of x is equal to m. Let c be a constant, then each of the following statements holds. For the sum law, limit of as x tends to a of f of x plus g of x, is in brackets, is equal to limit as x tends to a of f of x plus limit as x tends to a of g of x. That will be equal to L plus M. The difference law, limit as x tends to a, or x approaches a, of f of x minus g of x, in brackets, equals the limit as x approaches a of f of x minus limit as x approaches a of g of x. That is equal to L minus M. The constant multiple rule, limit as x approaches a, c times the f of x is equal to c times the limit as x approaches a of f of x, that is equal to c times L. The product loss is a limit as x approaches a of, in parentheses, f of x times g of x is equal to the limit as x tends to a of f of x minus limit as x tends approaches a of g of x, that is equal to L times M. The quotient law says limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f of x over the limit as x approaches a of g of x. It will be equal to L over M, provided that M is not equal to 0. The power law says the limit as x approaches a of f of x raised to the n is equal to bracket limit as x approaches a f of x bracket raised to the n, that is equal to L raised to the n for every positive integer n. And finally, the root law, limit as x approaches a of the nth root of f of x, as n is even, is equal to the nth root of the limit as x approaches a of f of x, equal. That will be equal to the nth root of L for all L if n is odd, and for all L greater than 0, greater than or equal to 0 if n is even 1. Limits of polynomials and rational functions. If p of x and q of x are polynomials, the limit as x approaches a of q of x is not equal to 0, then the limit as x approaches a of p of x is equal to the p of a, and the limit as x approaches a of p of x over q of x is equal to p of a over q of a. In other words, if we have polynomials or rational functions, we can simply just plug in the value for a, the numerical value for a, and then just solve. And once you solve that polynomial expression or that rational expression, you get a numerical value, and that is the answer. Okay, so let us look at a problem. the limit as x approaches -3 of 2x squared plus 3x in parentheses. If we did that problem by just plugging in, so let's say we just plugged in -3, that would be equal to 2 times -3 squared plus 3 times -3. It's going to be equal to 2 times 9 minus 9. It's going to be equal to 18 minus 9. That would be equal to 9. If we apply the sum rule to the same problem, so another way to do it is to apply the sum rule. If we apply the sum rule to this problem, what we'll have is that this limit as x tends to or approaches -3 of 2x squared plus 3x, all in parentheses. We break this down into two limits. This limit as x approaches -3 of 2x squared plus the limit as x approaches -3 of 3x. The next step, we'll plug in our -3 into the x right here. And so we have 2 and -3 squared plus we plug in the -3 for the x on the next limit, and that will be 3 times -3. And so we have 2 times -3 squared, that's 2 times 9, that minus 9, and that's 18 minus 9. We still get our answer to be 9, so we get that in two different ways. Okay. Now let's look at an example where there's a rational function that we can plug in. So let's look at number 3. And so that's the limit as x approaches -1, x minus 5 over times 2x plus 1. All of that is over x squared minus 3 cubed. Now let's just do it by directly plugging in -1 for x, so that would be equal to -1 minus 5 times 2 times -1 plus 1 all over -1 squared minus 3 all cubed. Let's continue doing the algebra there. And what we have is -6 times 2 times -1 plus 1, that will give you -1 all over -1 squared, that is +1 minus 3. It's going to be a -2, -2 cubed. That will be a -8. So that would be +6 over -8. So that would be -3/4 as your final answer. Okay, that's your final answer. Alrighty. Now let us look at another rule. This rule is about taking limits of trig functions. It says that if c is a number in the domain of a trig function, then limit as x approaches c of f of x is equal to f of c. That means the number that x approaches, if you plug that into the function value, the value for the function, or the input for the function, and you solve that, then that will be your answer for the limit as x approaches c. So let's look at an example where we have a limit as theta approaches pi over 2 sine squared theta. So what we will do is that we will plug in pi over 2 That's our value for theta, so it's going to be equal to sine squared pi over 2. And we know that the sine of pi over 2, or unit circle, that was equal to 1, so that's 1 squared. That's equal to 1. So that's our final answer. Okay.